Hi, everyone, and welcome back to JSA TV and JSA podcasts, where we're covering the latest stories, trends, and innovations from leaders in global connectivity, real estate, and the networks within. I'm Barb Mitchell from JSA, and I'm joined here by Paul Ehvert of Ehvert Mission Critical. Paul, thank you so much for joining us. Tell us a little bit, if you wouldn't mind, about Ehvert Mission Critical.
Yeah, absolutely. And thank you so much for having us. Yeah. So Ehvert Mission Critical, we're an MEP engineering firm who focus specifically on the data center market. We're based out of Dallas, Texas, but as you may be able to gather from my accent, I'm actually Canadian. So based in Toronto and very happy to be here, missing a bit of the snow at home.
Yes, I know. We both left a little bit of snow behind, but and I believe... am I right to say this is your first PTC?
First time attending, and so far it's been fantastic to collaborate and connect with peers in the industry. So have been enjoying the weather and the conversations amongst colleagues as well.
Such a great way to kick off the year, and so many great conversations and people to meet. Let's start with this conversation here today. So, I think when you told us a little bit about the company, but when we think about just the massive growth that the data center industry has experienced globally, tell us about how virtual design and construction is really helping to revolutionize the industry.
Yeah, absolutely. And happy to. And as you mentioned, the data center industry is really just exploding. And the demand that AI is now placing on the industry is taking that to a whole nother scale. So the growth of projects we're seeing, it felt not that long ago that a project that was 10 to 20 megawatts of IT load was considered a large project, where now the norm for a campus is in the hundreds of megawatts. So the scale is astronomical in terms of what we've seen in recent years. And then in terms of delivering these projects, the schedules that our clients are looking for us to adhere to are the same as they were previously, and in some cases, even shorter. And then no matter which market we're operating in, we find resources are constrained to some capacity. So our goal with virtual design and construction technology and how we implement it into our engineering practice is really just to improve communication and leverage the expertise of all stakeholders on the project. We work with really qualified project teams, and as engineers, we want to factor in all of their knowledge right at the onset of design. So we're factoring in constructability and maintainability, which are often not thought of until later on in the process. We're really looking to bring all that team's information right up to the beginning. One of the main ways we're doing this is they're called 4D models, where we tie our traditional 3D building model to the project schedule, and it allows us to sequence the project and visualize how the project is going to be executed, a dry rehearsal of the construction process to see how we can improve our designs to accommodate construction and operations factors.
Right. And there are so many factors, right? I mean, it's so many different things that need to be considered in the construction process, and the inputs and outputs and connectivity and all the different things. But one of the things, of course, is the electrical systems, and such a major part. We talk about the energy in and out of data centers, all the time. But how are these electrical systems being designed to really ensure optimal performance?
Yeah, so absolutely. And I find as power demands are exponentially increasing, the complexity and the completion of our designs is having to evolve to match kind of the demand of the centers we're working in. Yeah. So I think traditionally we saw engineers completing designs to a schematic level, where we find we have to go into a lot more detail now in order to ensure the efficiencies of our electrical systems are maintained. So whether that's construction level detailing on some components or working with manufacturers to really make sure we're getting as much efficiency as possible, because any percentage saved on a project of this scale is massive. And then also as well, what's really important is that we factor in safety into our designs. So whether it be doing coordination studies or arc flash studies as a part of the design, not only do we want to make sure that our electrical designs are efficient, but that they're as safe as possible for our operators and end users. So efficiency is nothing without safety as well.
Right. And I mean, another thing that's important, I believe, for data centers is just the continuity and reliability and uptime and all these different things. But When you think about that from the mechanical systems and how you ensure that they are just operating seamlessly, can you talk about that?
Yeah, of course. So I think a lot in the mechanical design, we do a lot of simulations, whether it's computational fluid dynamics or hydraulic calculations on the piping side. A lot of simulation goes into the early stages of our designs. And we're doing that kind of same level of detail that I mentioned kind of previously with the modeling and the sequencing to make sure our mechanical designs are as efficient as possible. And then naturally, as we're moving to liquid to chip and our cooling strategies are evolving, because the only way we can really deal with the heat, especially these AI demands are producing, is a completely new mechanical strategy. And I know some of my colleagues and peers here today are speaking about it, but really developing that next level of mechanical cooling strategy and a kind of departure of the traditional air-cooled methodology and the level of detail and coordination and design that is involved in that direct-to-chip cooling. While it requires a lot more coordination and detail, it's ultimately necessary to ensure optimum performance and efficiency.
Right. So, I mean, Paul, thank you so much for giving us this quick flyby introduction. And I think there's so much more that people will likely want to hear from you. How can they find you? How can they connect?
Well, I will be here. I'll be on the beach, but make sure you look for me with a shirt on if I'm out there.
Okay.
But otherwise, I'll be around and looking forward to, I have some meetings set up with colleagues, but looking forward to connecting at social events over the course of the event, or whether it's just in the conference hall. So thank you so much for having me today and looking forward to speaking with everyone here at PTC.
Yeah, thank you so much for joining us. We really, really appreciate you pulled yourself away from the beach to get here. So we appreciate it. And thank you to our viewers for tuning in today to JSA TV and JSA Podcasts. Happy networking.